Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve a quadratic equation by factoring a trinomial when a is equal to 1. Now, you can see I have a couple equations here, and then I also have one where I have it's equal to y or it's equal to f of x, which basically the description would be like find the roots of the function, or find the zeros of the equation. And so really the process is exactly the same. I just wanted to represent that because even though I'm focusing mostly on equations, those types of problems are exactly the same process. And the main important thing is when we're solving a quadratic, basically we're looking for the values of x that are going to make this equation true. And unlike linear equations or some other different equations, we have two variables. And the variables we cannot combine. We have an x squared and an x, so they're not like terms. So we can't use inverse operations to quickly solve when we have two variables that are not like terms. So what we need to do, the first step, is to always make sure we have our equation set equal to 0. Even if we have a function or another equation, we need to set it equal to 0. Then what we're going to do is we're going to look to factoring. We're going to take our trinomial and rewrite it as the product of two expressions, so therefore we can apply the zero product property. The main important thing is being able to apply the zero product property to allow us to go ahead and solve a quadratic. So by factoring, that's the only way we're going to be able to get it done. All right, so you can see in this case we have my quadratic equation. It's set equal to 0, so now I can apply factoring. All right, so the first thing that we are going to do when we're looking into factoring, again, I need to rewrite this as a product of two expressions. So my favorite mode to go ahead and do this is to use what we call the diamond or the x method. So basically what I'm going to do is I'm going to create a nice little x. And on the x, I'm going to write well, let's see. All right, so a quadratic, we have ax squared plus bx plus c. That is the standard form of a quadratic equation. All right, so basically what we're going to do is we're going to determine what two values add to give you b, but then multiply to give you c. All right, so in this case, you can see we have c is 30, and then we have negative 11. So we want to find the values that multiply to give us 30. Now, some of you might be able to do this in your head, and you say, oh, OK, it's these two numbers. Some of you might be like, I have no idea what two numbers multiply to give you 30. So the best way to do this is to then go ahead and start listing out all the numbers that multiply to give you 30. So if I have 30 here, just want to make sure. OK. So if I have 30, I can break that up into 30 times 1. I could do 15 times 2. I could do 6 times 5. And I could do 10 times 3, and I could do 6 times 5. Now, it's best when you're factoring out these to always start with the first number, 30 times 1, and then keep on going to the larger and larger numbers on down. Now, I got to figure out which of these factors add to give us negative 11. Now, remember, these numbers multiply to give us 30. So if you're looking at two numbers that multiply to give you 30, that could be two positive numbers, or it could also be two negative numbers. Since they have to add to give you negative, we know that two positive numbers can't equal negative. So we got to look for which of these two factors, since they're going to be negative, add to give us negative 11. And those two values is negative 6 and negative 5. So I'm going to write negative 6 and negative 5 right there. Now what I can do is I can rewrite my product as two binomials set equal to 0. So basically what we can do is I can write this as x minus, let's write this right here, x minus 6 times x minus 5 equals to 0. All right? And if you want to apply FOIL, again, you can always check your answer by applying FOIL, and they will expand out to x squared minus 11x plus 30. But now I have two quantities set equal to multiply to equal to 0. So therefore, now I can set them both equal to 0. X minus 6 equals 0, and x minus 5 equals 0. Now I just add 6, add 5, and I obtain x equals 6 and x equals 5, or the solution set 6, 5. OK? So basically, ladies and gentlemen, that's really what we're going to be doing here. Because when you're looking at the factors, I don't want to go through the whole definition, but that's basically what you're doing. You're looking into what two numbers multiply to give you 30, or multiply to give you your constant, and then add to give you your coefficient of your linear term, or that middle term. So let's go ahead and do another one. That kind of sounds like fun, right? OK, so B and C. So B in this case is 21. C in this case is 38. So let's go ahead and write out what gives us 38. Well, we could do 38 times 1. We could do 19 times 2. And 4 doesn't go in there. So that's it. So then we need to determine, well, which of these add up to give us 21. Now, since our middle term is positive, we know that these two terms also have to be positive. And you can see that my two values are going to be positive 19 and positive 2. So again, I'll write x plus 19 times x plus 2. And that's already equal to 0. I didn't really explain it. Since the 0 is on the left-hand side, it doesn't really matter. As long as your equation is set equal to 0, you're good. Now you have a product of two expressions equal to 0. Apply the 0 product property. Set them both equal to 0. So I have x plus 19 equals 0 and x plus 2 equals 0. Subtract 19, subtract 19, subtract 2, subtract 2. X equals negative 19. X equals negative 2. So therefore, my solution set is negative 19 and negative 2. All right, so let's go and get into this case. Now, again, remember, I kept on emphasizing you have to set your function equal to 0. Well, basically, when we're solving an equation, we're making this equation true. This equal to 0. What values make that true? So in this example, I don't have it set equal to 0. So if you're looking to solve, find the values where the x is going to make the equation equal to 0. Then simply just replace f of x with 0. Okay, because that's exactly what we're looking to do. Where you're solving for the roots, the zeros. If you have your equation set equal to an f of x or a y, then replace it with 0 so you can solve. So again, now we're looking into what two numbers multiply to give me negative 27, but then add to give me a negative 6. Now this one's a little bit, now this is helpful. Because now in this case, our two numbers have to multiply to give us negative 27. See here, they had to multiply to give us a positive 38 or a positive 30. So our two factors could either be both positive or both negative. But now our two factors have to multiply to give us a negative number. That means one's going to be positive and one's going to be negative. Well, how do you know if they're going to be which one's positive, which one's negative? We look at the middle term. Since the middle term is negative, that means the larger of the factors has to be negative. All right? So what that's helpful in this case is because let's go ahead and list out the factors of 27. I could do 27 times 1. I could do 9 times 3. And that's really about it. Now remember what I said. The larger factor has to be negative. So therefore, you just make these both negative. And you say, all right, out of 27 plus 1 or negative 9 plus 3, which one gives us negative 6? Again, that works. And again, the larger one was negative because one of them had to be negative because of the product. And then the middle term is negative. So that means the larger number had to be negative. So now I have my two factors, which is negative 9 and positive 3. So therefore, I now write this as x minus 9 times x plus 3 equals 0. Now I can go ahead and solve. Set them both equal to 0. X minus 9 equals 0. X plus 3 equals 0. So therefore, my solution set is x equals negative 9 and x equals negative 3. I'll spare myself the solving ways. OK? All right. So in the next one, you can see that the equation is now, it's not even set equal to 0. I have variables on the left side. I have variables on the right side. What exactly are we going to do? Well, in this exact case, all we're simply going to do, again, is get everything over to one side so it's set equal to 0. So to do that, I'm going to have to add a 2x to both sides. And I'm going to have to subtract a 15 to both sides. So therefore, I end up with the equation x squared plus 2x minus 15 equals 0. OK? So therefore, now I can look at this and I can say, all right, I'm looking for the product of what two numbers multiply to give me a negative 15 and then add to give me a positive 2. Now, unlike this last example, I know my factors have to, one of them has to be negative. But now, since they're adding to give me a positive, the middle, the larger of the factors has to be positive. So what are the factor? What do they? What do the two numbers? Oh, so I got to find the factors of negative 15. So I say negative, or forget about the negative. Let's just take 15. Doesn't really matter for right now. So we do 15 times 1, 5 times 3. That's it. But remember, we said the larger number had to be positive. That means the smaller number is negative, right? Because that's going to make that positive. This one had to be negative, right? One of the factors has to be negative. So you can see that the only numbers that work and give you positive 2 is a positive 5 and a negative 2. Again, write them as your binomials, as the product of two binomials. So that's going to be plus 5 times x minus 2 equals 0. Now, you take both product and you set them equal to 0. So you have x plus 5 equals 0 and x minus 2 equals 0. Solve for x. You get x equals negative 5, x equals 2. Solution set, negative 5, positive 2. OK, over here, again, I have my variables on the left side, but I still have them equal to 40. Having an equation equal to 40 is not going to help you. It has to be equal to 0 so you can apply the zero product property. So I'll subtract 40. And I obtain x squared minus 3x minus 40 equals 0. Now we need to, again, determine what two numbers multiply to give you 40, but then add to give you negative 3. So therefore, you take 40 and you say, all right, what numbers multiply to give me 40? Well, I have 40 times 1. I have 20 times 2. I have 10 times 4. And I have 8 times 5. Now again, remember, they're going to add to give you a negative number, right? So therefore, since they're adding to give you a negative number, the larger of them has to be negative. So we say, which one of these adds to give you negative 3? You can see it's negative 8 and 5. So I do negative 8 and 5. I'll write just the quantity and then write the expression. So I have x minus 8 times x plus 5 equals 0. Now you set them both equal to 0 and solve. And what you get is x equals 8, x equals negative 5. So you have 8 comma negative 5. All right, last example, just like the one ahead of it. If you have an f of x equals or y equals and you need to solve, you need to find the values of the equation that make the equation true when it's set equal to 0. So simply just replace the y with a 0. Now, you can see that I have a 2 in front of the x. And in all of these, all my x squareds, I had a coefficient of 1, right? Well, so in this problem, what you always want to do is always look to see if you can factor out a common term. You can see that every one of these terms are divisible by 2. So I'm actually going to factor out a 2. Okay. Now, by factoring out the 2, now I can apply this quadratic. And well, basically, to get rid of the 2, just divide by 2 on both sides, right? Because that times that is equal to 0. So I'll just divide by 2. And so I'm left with 0 equals x squared plus 5x minus 24. So multiplying by 2 is really not changing anything. Now I just need to determine what two numbers multiply to give me negative 24, but then add to give me a positive 5. So you could also start doing this stuff in your head. And in this case, I could say what two numbers? I know that 8 and 3 have a difference of 5. Since the 5 is positive, that means 8 is going to be positive. So I have 0 equals x plus 8 times x minus 3. Again, I can check my work. 8 times negative 3 is negative 24. X times x is x squared. And 8 times x plus x times negative 3 is positive 5x. So therefore, set them both equal to 0 and solve. And you get x equals negative 8 and x equals 3, and a solution set of negative 8 comma 3. So there you go, ladies and gentlemen. That is how you factor a trinomial to solve your quadratic equation. Thanks. Hello. Hello.